Welcome to Rivera Institute of Mathematical Sciences. Today we are discussing some problems of linear algebra from CSIR November 2020. First one, let capital A be an n by n matrix such that the set of all its non-zero eigenvalues has exactly r elements. Then which of the following is true? Okay, for that here I consider a matrix capital A equal to 0, 1, 0, 0. Here this is an upper triangular matrix with all its diagonal entries are 0, and we know that an upper triangular matrix with all its diagonal entries are 0 is a nilpotent matrix, and all the eigenvalues of a nilpotent matrix are 0. So here r equal to 0. What is r? R is total number of non-zero eigenvalues of that matrix. So here r equal to 0, and what is the rank of this matrix? Rank of this matrix equal to 1. Okay, now consider the four options. For the first option, what is rank of A? Rank of A equal to 1, and here r equal to 0, and given that rank of A is less than or equal to r, that is 1 less than or equal to 0, it is not possible, therefore option A is false. Now consider option B. If r equal to 0, here r equal to 0, then rank of A is less than n minus 1. Here rank of A equal to 1, and here I choose capital A is a 2 by 2 matrix, therefore n minus 1 equal to 2 minus 1 equal to 1. 1 less than 1, it is not possible, therefore option B is also false. Now consider option D. Okay, A square has r distinct non-zero eigenvalues. For that I consider a matrix capital A equal to 1, 0, 0, minus 1. This is a diagonal matrix, so its eigenvalues are diagonal entries. What are the eigenvalues of this matrix? The eigenvalues of this matrix are 1 and minus 1. That implies r equal to 2. R is the total number of non-zero eigenvalues, so here r equal to 2. And what are the eigenvalues of A square? The eigenvalues of A square are 1 square, that is 1, and minus 1 square, which is also 1. That is total number of distinct eigenvalue. Here only 1 is the eigenvalue, therefore A square has r distinct non-zero eigenvalues is wrong, therefore option D is also wrong. So here only option C is true. And how can we prove option C is true? Okay, for that here given that R is the total number of non-zero eigenvalues, that is number of non-zero eigenvalues equal to R. Okay, for an n by n matrix it contains total n eigenvalues, right? So total number of, what is the total number of zero eigenvalue? Number of zero eigenvalue equal to, we know that number of zero eigenvalue equal to total number of eigenvalues minus number of non-zero eigenvalues. Here number of non-zero eigenvalues equal to r, therefore total number of zero eigenvalue equal to n minus r. What is number of zero eigenvalue? It is nothing but algebraic multiplicity of 0, that is algebraic multiplicity of 0 equal to n minus r. And we know that geometric multiplicity of an eigenvalue is always less than or equal to algebraic multiplicity of that eigenvalue, right? So geometric multiplicity of 0 is less than or equal to algebraic multiplicity of 0. And what is algebraic multiplicity of 0? It is n minus r. That implies geometric multiplicity of 0 is less than or equal to n minus r. And what is geometric multiplicity of 0? It is nothing but nullity of that matrix, that is nullity of A is always less than or equal to n minus r. Okay, now consider, we know that by rank nullity theorem, rank of A plus nullity of A equal to n. That implies rank of A equal to n minus nullity of A. Okay, here nullity of A is less than or equal to n minus r. That implies minus nullity of A is greater than or equal to minus of n minus r. That implies minus nullity of A is greater than or equal to r minus n. That is rank of A equal to n minus nullity of A. That implies rank of A is greater than or equal to n plus r minus n, that is rank of A is greater than or equal to r, therefore option C is true. Okay, Next one, if capital A equal to 3 minus 2, 2 minus 1, then the value of A raised to 20 is. Here given that capital A equal to 3 minus 2, 2 minus 1. Okay, we can write this A as identity matrix plus some other matrix, that is 2 minus 2, 2 minus 2. Here 2 plus 1 is 3, minus 2 plus 0 is minus 2, 2 plus 0 is 2, minus 2 plus 1 is minus 1. That is capital A can be written as identity matrix plus B. Okay, now consider the matrix capital B. What is B? B equal to 2 minus 2, 2 minus 2. Here each row sum of B is 0, that is 2 minus 2 equal to 0, 2 minus 2 equal to 0. So 0 is an eigenvalue of this matrix. 0 is an eigenvalue of B. And we know that trace of a matrix is the sum of the eigenvalues. Trace equal to sum of eigenvalues. What is trace of this matrix? 2 minus 2, that is 0. That is 0 equal to sum of eigenvalues. One eigenvalue is 0 and the remaining eigenvalue is B. That is B plus 0 equal to B. That implies B equal to 0. So we get the two eigenvalues of this matrix is 0. For a 2 by 2, for an n by n matrix, all its eigenvalues are 0 implies that is a nilpotent matrix. So here it is a 2 by 2 matrix and all the eigenvalues are 0. So it is a 2 by 2 nilpotent matrix, and we know that for a 2 by 2 nilpotent matrix B square must be 0. If B square is equal to 0, then B cube equal to 0, B etc. up to B raised to any power equal to 0. Now we have to find the value of A raised to 20. Okay, what is A raised to 20? A raised to 20 equal to A is nothing but identity plus B. Identity plus B all raised to 20, and we know that the binomial expansion A plus B all raised to 20 equal to A raised to 20 plus 20 C1 into A raised to 19 B plus 20 C2 into A raised to 18 into B square plus etc. up to B raised to 20, right? So here identity plus B all raised to 20 equal to identity raised to 20 plus 20 C1 into identity raised to 19 into B plus 20 C2 into identity raised to 18 into B square plus etc. up to B raised to 20. We know that B is a nilpotent matrix, 2 by 2 nilpotent matrix, therefore B square equal to 0, B cube equal to 0, etc. up to B raised to any power equal to 0. So all these term will vanishes. That is, this will become identity raised to 20. What is identity raised to 20? It is identity itself, that is 1001 plus 27 is 20 into identity raised to 19 into B is B itself, that is 20 into 2 minus 2, 2 minus 2. So this will become 1001 plus 20 into 2, 40 minus 40, 40 minus 40. So this will become 1 plus 40, that is 41 minus 40, 40 minus 39. That is option, which option is true? Option B is true. Okay.